everyone. Thanks for having me. I'm so glad to be here today, though I really look forward to the day that I can see the people I'm talking to and not just myself. So coming to PICS just over 2 years ago, I started having conversations with a bunch of built environment stakeholders. And the issue of embodied carbon kept bubbling up. CLF Vancouver had just recently formed, and the city of Vancouver was already being looked to as a leader in this space. So I saw that as some really exciting momentum that I could build on, trying to find ways for local and regional governments to play a greater role in reducing embodied carbon. At the same time, I read a really compelling critique of decoupling emissions from growth. So the theory of green growth suggests that we can have just as much economic growth as we always have, but we can reduce emissions at the same time. In BC, this appears to have happened already. But this really depends on what emissions we count. So conventional emissions accounting looks at territorial emissions from fuel combustion, agriculture, waste, transportation, and manufacturing. But it excludes the emissions from industrial processes and transportation for all of those products produced elsewhere that we end up consuming within a territory. So unless and until we decouple growth from emissions globally, we won't actually be addressing the root of the problem. The decoupling will just be relative. So the rising interest in embodied carbon and this critique of decoupling are really getting at the same thing, that we need to address the underlying emissions that are so often neglected in conventional accounting. So you can slice and dice global emissions in a lot of different ways, but one of the standard ways is to look at industry, buildings, and transportation. And when you do that, buildings play a huge role. So operational emissions have been declining, but when you look at manufacturing for steel, concrete, and aluminum, those are still incredibly carbon intensive. For both buildings and infrastructure, those comprise around 23% of global emissions. As operational emissions continue to decline, embodied emissions become an even greater issue. But even if operational emissions stayed steady, embodied emissions are substantial. And it's really important that we emit the embodied part now, and we can't take that back. And so what that means is that as built environment professionals, we can also do something about that now. So just to clarify, embodied emissions occur across the construction life cycle. Operational emissions occur only during building use, but embodied emissions occur during material extraction, transportation, manufacturing, construction, demolition, and disposal. A number of influential global organizations have been working on this issue and developing policy frameworks to tackle it. So for example, the World Green Building Council issued a major report on bringing embodied carbon up front, and they suggest that building nothing has the highest carbon reduction potential. The Carbon Neutral Cities Alliance, which the City of Vancouver participates in, offers an embodied carbon reduction pyramid. So there's a hierarchy built in here. At the base of the pyramid, the strategy that would have the most impact is redefining the solution. So that means finding alternative ways of fulfilling our space and construction needs by occupying underused spaces or building green rather than gray infrastructure. Building on this, I laid out a framework that emphasizes just how much work and what type of work would have to be done. So in order to tackle this, we really have to acknowledge that reusing materials and reusing buildings would require a transformational shift at a social and cultural level. There's not a simple technical fix. And speaking to the crux of the session today, which is about bringing embodied carbon and the circular economy together, I categorize embodied carbon strategies in two major buckets. So first, material performance, and second, circular economy. So I'm seeing circular economy as a subset of embodied carbon. Material performance includes the strategies that are most widely associated with embodied carbon. So that's lower carbon materials and material efficiency. Circular economy strategies, I would suggest, are more holistic, and these include material reuse and building reuse. We're seeing material reuse already. There's a lot of it happening in the Lower Mainland and South Island. Unbuilders is leading the way here with material salvage and reuse and the Rebuild Hub at Habitat for Humanity. But the strategy, which is the simplest on its surface, which is reusing buildings, is really going to be the toughest in practice. Ultimately, this would mean fulfilling demand for new buildings with existing buildings. So just further tying together the circular economy and embodied carbon, I wanted to overlay this on that building phase diagram I showed before. So you can look at how the circular economy really fits in. So again, the hierarchy is important here. We've got to look at the highest and best use in terms of circular economy. So if you look at the use stage, it's really about longer use and intensifying use. And then from there, moving to reuse, remanufacturing, and recycling. In response to the challenge of reducing embodied carbon and through the extensive research and engagement that I did, I found a substantial overlap between the material performance and circular economy strategies with existing, sometimes decades-long urban sustainability work in the domains of waste, equity, and preservation. So in essence, this response is all about reuse, not just reusing buildings, but reusing all of this existing work that's been going on, the existing knowledge and the policy pathways. The circular economy is at the center of this because it has the potential for the biggest impact. In a minute, I'll go into details about the opportunities in these three areas, but first I want to talk a little bit more about the advantages of taking this approach. First, for advancing the agenda, and second, for actually having an impact on emissions. So to advance the embodied carbon agenda, there are a number of advantages to integrating embodied carbon into core urban sustainability work. First, to many practitioners and policymakers, embodied carbon may appear to be a new frontier that requires a whole new technical apparatus to address it. This can be really daunting and cause some people to just disengage. But making stronger links to a larger urban agenda creates the opportunity to build a much broader constituency of support. You don't have to be a champion for embodied carbon per se, you just have to recognize it as a co-benefit. People on this webinar are probably really excited about embodied carbon, but I'd suggest you're in the minority. But there are well-established interest groups with dedicated bases devoted to waste, equity, and preservation. So this approach can make embodied carbon a mainstream concern. Put simply, integrating embodied carbon is pragmatic. It reduces the startup effort required for introducing a whole new policy area. It's a shortcut to doing the work that needs to be done rather than spending a lot of time measuring and accounting for emissions. Centering reuse also offers opportunities for those low growth communities that are often left out of the climate policy debate. You know, they feel like they don't have a lot to contribute. But really, if new buildings and infrastructure are not the a priori solution, there is room for those communities to make a meaningful contribution and even tout low growth as an advantage. Finally, city policymakers like to lay claim to climate leadership. And taking on responsibility for emissions beyond boundaries is another way to do this. So I'd also like to go into the advantages from a carbon mitigation perspective. In all the work on using low carbon materials, one of the major proposals is to use a lot more wood, and especially mass timber and engineered wood. Some researchers have even argued that if we use engineered wood products rather than concrete and steel, the buildings can serve as a global carbon sink. But rather than looking forward to a future carbon sink, we really need to look back at the existing building stock in terms of the sunk carbon. So if we zoom out to a big picture perspective where we're considering the time dimension, it makes sense to not only think about the current upfront emissions, but the historical emissions. So if you're making a decision to tear down and replace a building or reuse it, consider all of the carbon that was emitted to originally make that building. To make this a little bit more concrete, it helps to look at a recent study from Finland that looked at a housing development of about 220 units. So these researchers chose to focus on a 50-year time frame because they decided that was most relevant to current climate targets. And they compared energy efficiency scenarios, base building code, moderate energy efficiency, passive house, and then renovating to moderate energy efficiency standard. And they found that renovating 1960s buildings to a moderate energy efficiency standard resulted in lower emissions over that 50-year horizon than any other option. This takes into account that upfront carbon spike, which is going to be inevitable with any renovation or construction project. And it points to just how important it is to consider operational and embodied emissions together. So the authors conclude that new construction cannot be used as a means to achieve short and middle term climate goals. And there are plenty of other researchers that are converging on that consensus. So with all of that in mind, let's start to get into some of the details, the strategies within those three domains of waste, equity, and preservation. Beginning with equity, retrofitting affordable housing presents a large opportunity. Across Canada, a large part of the affordable housing stock is in the form of older apartment buildings. And often these are not really performing well in terms of energy efficiency or occupant comfort. So upgrading those buildings means that you can address those operational energy problems while also preserving the embodied carbon. The Tower Renewal Partnership is an organization based in Ontario, and their whole mandate is focused on this. And so they've been advocating and working on actually upgrading these buildings across Canada. The Reframed initiative in BC, led by the Pembina Institute, is doing something similar. So for Tower Renewal, embodied carbon was certainly not their main motivation, but they see it as a co-benefit. And in a back of the envelope calculation showed that replacing an 18-story building rather than reusing it would actually take 180 years to pay back that embodied carbon. So in addition to retrofits, cities can build on the workforce development that's already been happening around deconstruction, material salvage, warehousing, and resale. Though I suggest that materially efficient new construction is a second choice, clearly there's still going to be lots of new construction. And so I think it's helpful to look at some of the major moves that we can make there besides just lower carbon concrete. So this is from a study that an architect in Toronto, Kelly Alvarez Duran, did with his architecture studio at U of T, looking at a sample of buildings across Toronto in terms of their underground parking. And they found that especially in mid-rise buildings, there was a huge impact on embodied carbon from that underground parking component, anywhere from 60 to 90%. So this suggests that if you look at buildings in their land use context, that there's a huge role for transportation, supporting the active and public transportation that makes it possible to remove underground parking. Moving on to preservation. The word connotes historic preservation, but I'm using it in the broadest sense. So in terms of retrofit and adaptive reuse as well. One of the biggest things that cities can do here is support building reuse through codes and incentivize it, potentially levying a tax or fee on new development. And even retrofits can entail a large amount of embodied carbon, so it's important to evaluate the impact of that. That Reframed initiative led by Pembina is planning to do an analysis of the embodied carbon in their affordable housing retrofits, so those will be some results to watch out for. Finally, in dense urban environments, vertical infill is pretty common, but there's still a lot more opportunity for that. So making the most of existing structural capacity by building additional floors on top of existing buildings. There's an emerging business case for extending the life of buildings. Arup and the Ellen MacArthur Foundation have done some preliminary work based on case studies in Europe, where they identified major sources of lost value and some ways to recapture that value. So in response to premature demolition, they propose making assets more adaptable through retrofits and alternative investment models. In response to underutilized space, they propose flexible leasing arrangements. And in response to underperforming components, they suggest a product as a service model. So in that sense, lighting, carpets, even the building envelope can be owned over the long term by a service provider, which creates a form of extended producer responsibility. Finally, waste is a major opportunity. It might seem that requiring deconstruction would have the biggest impact, but so far, based on contractor experience, it seems that waste regulations really have a much bigger impact. So that's banning things like clean wood from the landfill. But then reusing those materials is another matter, and that material reuse is still not well tracked and not well supported. Finally, when it comes to new construction, there are multiple stages where material efficiency should be highlighted, and that's everything from design through construction. So that gives a sense of some of the opportunities to take advantage of existing work in waste equity and preservation to achieve linked embodied carbon and circular economy goals. But there's still a huge need for research and development, and I've been pushing forward a few projects. So first, building on the work with the commercial real estate sector that Eric began, I'm working with Circular Economy Leadership Canada, industry associations, and real estate firms to explore an alternative business model for prolonging the life of buildings. We're still just pulling partners together, so if anyone on here is interested, please let me know. Also, PICS has funded a project with the City of Victoria to develop a framework for making decisions on operational emissions. And we're going to add an embodied carbon component to that, looking at densification tipping points. So basically, if you replace 2 single-family buildings with a small multi-unit building, how does that shake out in terms of embodied carbon? And we'll look at a number of different replacement scenarios. So the framework I presented today is really just a way of thinking about embodied carbon in the circular economy, but now there's a need for municipalities to make it more concrete. And I'm working with an organization in 2 small communities in BC to start to develop more concrete regulations. That project hasn't been announced yet, so it should be coming out soon, but hopefully that will provide a policy template that a lot of smaller communities can take up. So throughout, this has been a really iterative and responsive process. So I'm very interested in your questions and feedback. Please let me know if you're interested in getting involved in any of these projects, and also if you see other directions for research that you think are really important. Thank you.